Today, I'm going to talk about AI, and more specifically, 2 rules I use to determine whether AI is a good fit for a problem or not, as well as a few good use cases that show you where AI is best suited for. I'm Matt Grace, Managing Director of Flying Donkey. Let's get into it. Alright, let's look at the 2 rules I use to determine whether AI is a good fit for a problem. Firstly, is there a massive set of data that the AI can use to learn on? And secondly, how many variables are used in the problem? And finally, I'm going to go through a few use cases where AI is an excellent fit, or where an existing rules-based system might be better. But let's take a look at rule number 1. You have a large set of data. AI is a learning system, and what that means is it needs a large set of data to be fed into it in order to generate the rules that it can learn from. If your problem doesn't have a large set of data, then AI isn't going to be a good fit for that problem. Traditional rules-based programming doesn't need any large sets of data to code from. A programmer is simply coding if this, then do that. And he can simply do that by extrapolating from the data that he has. We recently did a review of one of our clients' systems, and throughout the entire system we couldn't find a single process where AI is a good fit. And the primary issue there was no large-scale pieces of data that could be used to train AI. Secondly, how many variables are used to solve the problem? To explain this one, let's look at an example. Marketing is a really good area for AI, and Google and Facebook do this really well. And the reason for this is that marketing has a huge amount of variables that go into it. Now, if we take a look at marketing, the idea is to try and get the perfect ad in front of the perfect person. If we take the audience for the moment, the audience has a huge amount of variables you need to cater for. Essentially age, gender, location, likes and dislikes, etc. And it can go into the hundreds, potentially thousands. And this is perfectly suited to AI. There is many variables involved that potentially impact the outcome in different ways. For a rules-based system, if it had this many outcomes, it would be very onerous to develop. Generally speaking, I like to see about 20 to 25 variables for AI in order to allow it to maneuver some of those variables to achieve the outcome. Anything less than this, and realistically, you're not looking for enough variables for AI to do its job, and it could probably be simply done more in a rules-based system. Now we've had a look at a couple of rules I use to determine whether AI is a good fit for a problem, let's look at a couple of use cases to determine which one should be used. Let's have a think about filtering and search on the web. And for the moment, let's exclude things like text search and Google search. And let's think about when you're on an e-commerce store and you're trying to filter by brand or price. When filtering by brand or price, these are very particular filters. You select your range for your price or your brand that you're going for. This is really well suited to a rules-based logic because it's already pre-filtered and ready to go. On the other hand, if you're trying to work out what the impact of COVID has been on the Australian GDP, this problem has the 2 main things we've talked about in AI. 1, that has a large set of data to pull on, and 2, there's huge amounts of variables. And this can be seen really easily. There's a huge range of factors that impact GDP, and this will help AI determine on which of those factors is impacting the most. Coding something here to determine the GDP is potentially possible, but hugely onerous. And this problem is much more suited to determine by AI. We previously discussed marketing as another good fit for AI, but here's some other really good use cases of AI that I've seen. Detecting financial transaction fraud. Detecting financial transaction fraud is where you try and take a large set of transactions and work out which ones are going to be fraud-based. Again, you can see here there's a large set of data with a huge amount of variables. Now these are previously done by rules-based systems, but it made it very easy for people to get around these systems because once they knew the rules, they could do things differently. AI uses these variables and learns over time and adapts to the fraudsters. This is a good fit for AI. Another great example is facial recognition. Now, facial recognition is used all day, every day on your smartphones to put a box around your face when you're trying to take a photo, as well as on Facebook when they're trying to tag your friends. Again, now think about this, it's got the 2 key things. 1, it's got a large set of data, which is the treasure trove of photos that Facebook has. And secondly, there's a huge amount of variables on a photo that can be determined on where your face is. Lighting, colors, background, complexions, all these things feed into where your face could be. Coding something that's rules-based for this problem can be very difficult and near impossible, because the AI, the large set of data, and the number of variables make it very good fit for the AI. And finally, another great thing is working out intent within text. This is generally called natural language processing, but it's trying to work out where you have a large scheme of text and working out what its intent is. That is it formal or casual? Is it angry or sad, etc.? There's already a few programs that do this. Grammarly is one, where it tries to depict from the text what you're trying to say and in what tone. And obviously this could be potentially helpful if you're in business and you're communicating in a more casual tone. You might want to change that to be in a more formal tone. But again, you can see the problem here. Large amounts of data, which is in the form of text, and huge amounts of variables, which is in the form of words. And this is why it's a great fit for AI. Coding something for this in a rules-based situation, again, is potentially possible. You'd have a huge amount of problem trying to work out all the different words and how they fit together to bring intent. Hope this demystifies some of the decision-making around whether AI is a good fit for your problem. At the end of the day, AI is just a tool, and you need the right problem for the tool to solve. There's no use trying to use AI in all situations, because potentially rules-based systems are better placed. If you're trying to use AI in your systems, or need help working out whether a problem suits AI, feel free to get in touch and we can try and help you out.